Good afternoon all. So I think my presentation will be a bit more easier because the first three presentations which has happened in the kind of chronological order, so that is going to support what I am going to talk about. So here I am going to further narrow down what we are going to talk about. I am going to primarily talk about the design for innovation and sustainability. How are you going to make the structure more easy, for making it more easy for recycling? Okay, so a brief introduction about the company, single slide. I'm not going to talk more. Only 2 points I want you to look into here. One is the number of tubes what we make globally. We make more than 8 billion tubes per annum globally. And in terms of the innovation, what we are going to be, if you see the kind of spread we have across, like Europe, we have 3 plants, America is around 4, and we have a very good presence in AMESA, that is India, and in case of EAP, that is China, we have a very good presence. And we have a very good innovation platform. We have filed more than 150 patents, and we have granted more than 90. Okay, so to make it, I'm just jumping straight, as I said, because a lot of introduction has been done. So let us understand what is it we are talking about in terms of a tube laminate. So in terms of tube laminate, if you see the conventional formats, there are 2 types of tube structures, what we normally say. One is called ABL, the other one is called PBL. ABL is aluminum barrier laminated tubes, and PBL is plastic barrier laminated tubes. So if you see the structure, both of them are having polypropylene caps, HDP in the shoulder. And if you see the body, in case of aluminum barrier laminate, we have aluminum as a primary material which is giving the barrier. While in case of a plastic barrier, it can be an EVOH, it can be a polyester, it can be polyamide, and generally the other things are LD and LTP. Now, what is in terms of what's currently happening in terms of the recyclability? Are they recyclable? Yes, they are recyclable. So, aluminum laminate is being kind of recycled or can be recycled into composite sheets, which can be further fabricated to make benches or something like that. While in case of a PBL, again, it is claimed to be recyclable in Recycle Code 7 because it has all plastics and it can be done. Now, what is the challenge what you are trying to do? So there are 2 primary challenges what we want to solve. So the first one is the ABL or PBL plastic tubes are actually in terms of volumes, although we claim 8 billion tubes globally, if you see as an individual stream, the volume is much lower. So if you want to be recycling this as a separate material, it becomes difficult, and generally it is not recycled into the same application. So if this has to happen, so first thing what we are trying to do is the first change what we want to make is making the tube formats compatible for recycling in pre-existing streams that are well accepted and being recycled in high volumes. In plastic, that's a big problem because we have so much kind of plastics and many of them are not compatible, like what Dr. Nema was saying. So we want to bring more compatibility by kind of reducing the number of plastics or the type of plastics what we are using. So that was the first thing. So what we wanted to do, we want to make the tube primarily made of HDPE so that this material can be designed for recycling in the HDPE bottle stream, which is one of the very well accepted recycled stream. Second is, okay, we are making the material recyclable, that's very good, but what are you going to do with the recycled granules? So if I want to make it purely cyclic, so I have to kind of take the material from the same stream in which a material is recycling, and I have to incorporate and replace virgin material. So that's the second thing what we want to achieve so that the model can be fully circular. And this is the gist of what we are talking about. This is the famous diagram of Ellen MacArthur Foundation in terms of how you make the entire model circular. And 2 things what we are talking about, the packaging design using single polymer resin, that's what is required. And second thing is incorporating the recycled resin content into this application what we are talking about. So what is the change what we did? So what you see on the left hand side, that's the one which is a conventional one, and the right hand side is what we have trying to promote now. So the cap is HDPE, the shoulder is HDPE, so we are trying to change the cap from polypropylene to HDPE so that it becomes recyclable together. And then in the body, instead of aluminum barrier laminate, we want to go for an HDPE based laminate with EVOH as the barrier. And generally what is accepted norm is if we have EVOH less than 5% in the total weight of the tube, it doesn't affect the compatibility of recycling into the polyethylene stream. So effectively by doing this, this material becomes recyclable in code 2. So that's what we wanted to achieve. Okay, so very simple. If you want to do it, please go and do it. Who is stopping you? But the issue is it's not so easy. There are a whole range of challenges which has to be overcome, because aluminum is one of the best barrier material known to us. So if I'm going to replace aluminum, what are the challenges what we have to face? So these are some of the challenges what we had to solve for this to happen. So first one is when you remove aluminum, the very important property which get affected is the barrier. So in terms of, let's say, toothpaste, one of the critical thing what we use is a flavor. Like for example, a mint flavor. Morning if you take Colgate and you try to brush, the flavor has to hit, which gives really, the brand actually tries to promote that as a unique selling proposition. And if that mint is not retained, you are not going to get this particular hit. So in order to get that, you have to have a very good barrier for keeping the material inside. So how are you going to do that? In a PBL laminate. Second is reduced tubing line speeds. So for example, the typical in flexible packaging industry, you know, aluminum is a very good connector of heat, and if I'm going to seal, if I give heat, aluminum absorbs the heat, kind of spreads it equally, it becomes more easier for sealing. But the moment I remove aluminum, it becomes plastic as an insulator. How are you going to get sealed? You can do it, but there is going to be a compromise on the line speed. So that's the second thing. Second thing is high tubability. Now I am trying to make HDP. For sealing HDP, I have to use a high temperature, because high density polymer requires a higher temperature of sealing. And if it is not cooled, it crystallizes. So when I make the tube, it looks pretty good, circular, but after 24 hours, 48 hours, all of them becomes kind of an oval kind of a shape. It becomes like a pear. And because of that, it cannot be used for filling, because the percentage is more than 8%, automated filling cannot be possible with that. That's an issue. Then difference in haptics. If you see a consumer, we are used to a particular type of tube feel. Like aluminum, when I'm going to press, it stays back. Plastics can come back again. So if the product is getting empty, you don't know. How are you going to solve that challenge? So which is the haptics what you're talking about. And last but not the least, the most critical one is the cost implication. Any change what I'm going to do, if the cost is not neutral, we'll have an issue. So we had worked through all these things, and effectively what we did, we launched a product called Platina. So this is one of the, you can say, successful brands what we have launched of late. Last 2-3 years we were doing this. Today, this year, we are going to like 20%. Like I said, we are doing almost more than 8 billion tubes. So somewhere around 1.6 billion tubes of sustainable tube formats is being sold this year globally. And the second challenge, what we are trying to do is how I'm going to incorporate the PCR, what I'm generating into the tubes. So this is our E10 range of tubes. Here we are able to currently, because again, PCR easier to say, but as we incorporate PCR, there are a lot of challenges, especially from the HDP bottle stream, because in our case, we make a blown film. So a blown film, when I'm taking it from the bottle stream, these are the problems what we face. We get a lot of gels, there are a lot of odor-related issues, color variation, and we also have lot inconsistency we have to dial in, because the grade will not be very consistent, performance it will not be there. So how are you going to address that? It's a question. So we have addressed all these things. We started with 30% PCR content. Today we have commercialized tubes with 50% PCR content. This is primarily available in the European market, because it has a cost implication. In India we are not able to sell this, but in Europe there is a great demand, and we are able to sell this in Europe. Now, are we going to stop here? No. Further, we are working on a lot of innovations are happening. So 2 more areas where we are currently working on is we are trying to reduce the product retention inside the tube. So for example, if I'm going to recycle, say, a toothpaste, normal toothpaste, if it is completely tried to, you take it out, you can make the product retention as low as, say, 5% or something like that. And if you're not completely squeezing out, maybe the product retention is almost 8 to 10%. And if it goes with that kind of paste for recycling, it becomes very difficult to cleaning, because what happens, these are products such as surfactants can give a lot of froth and all these things. So how are you going to overcome that, and can we make the product inside literally zero? So can we make the surface inside so smooth that no product stays in, completely it comes out? So that's one area what we are working. And the second one what we are talking about is printing. Printing again is one area where the color of the granule changes. It has a lot of regulatory challenges. So, but it has a lot of implication, because our end user customers have to work on this. So that's one area where we are working how to overcome this. So I think that's it what I have. Thank you.